Akkermans here, Supply Chain Dynamics Chapter 6, Sysdea Gameplay 1, the flow of cases. In this case, in this chapter, we look at the company Interpolis, or a part of it, Stichting Rijksbijstand, that assisted clients in dealing with legal cases, with dossiers as they're called in Dutch. And one of the key points of this case was that there was an imbalance in the amount of cases that the company had to handle because of a strong increase in recent years and indeed a continued increase in the inflow of new cases that was projected. It was quite clear that the number of cases that the company needed to handle was more than basically the capacity handling rate was able to cope with. So the company was faced with bringing first back this higher than normal amount of cases, and secondly with stabilizing then the capacity at the level that this case intake could be dealt with properly, but not too much and also not too little. So how do you deal with that? Well, we've already looked at the structure. So you've got an intake process and a work in process of cases, a case handling rate. The case in process divided by the case handling rate, there's little law, leads to a case handling period, so the duration of cases being handled. That's never shorter than, say, 2 time periods, 2 months. So in this formula we have a minimum of either all cases in 2 months or the process capacity available. How do we get process capacity available? Well, that's defined elsewhere in the model, but definitely it's clear that the amount of process capacity that you have available and the amount of process capacity that you need result in a workload. Workload is defined by capacity required divided by capacity available. If workload is as 1, then capacity is in equilibrium. If it's higher than 1, that means basically that you need to do more than you have staff to do. Because process capacity required is defined as the number of cases in progress divided by a target process duration. So you see here in this definition of inflow of cases, actually we had twice the number of cases that we should have had if we were in a steady state. Just to explain steady state once more. Steady state, what we like to do with simulation models is that first they behave really boring. Basically what goes in comes out also, so all flatliners here, and that's called steady state. And then when you change something, then you can look at the effects of the model. That's easier to understand what's the result of such a change. If everything is flat, then when, as in this case, there's already an increase. So the cases in progress here, if we would have made that completely flat, then there would have been no need to rapidly increase the amount of staff. But in this model we start already with a situation where there's more work than the people can handle. And then the question becomes, how do you deal with that in the best possible way?